The first tick of time is not a sound we can hear, nor a vibration that could ever have reached human ears, but it is something the imagination struggles to picture. In the silence before creation, there was no rhythm, no sequence, no before and after, only stillness, vast and unbroken. Then, something stirred. A spark, a fluctuation, perhaps even the trembling of a void that was never truly empty. The first pulse of time rushed outward like a ripple across an infinite sea. It was not light, not matter, not even space as we know it, but the scaffolding upon which all else would one day emerge. If one closes their eyes, one might imagine a dark expanse suddenly sliced open by a faint echo, as though reality itself exhaled for the first time. That invisible beat has never ceased, carrying everything forward in a relentless current. For ancient humans, the mystery of this beginning was a puzzle too immense to solve, yet too powerful to ignore. They looked up at the night sky, tracking the slow march of stars and the waxing and waning of the moon. To them, time was a cycle of rebirth and return, the seasons circling endlessly, life sprouting from the soil only to wither and fall, then sprouting again. Every sunrise was a reminder that time had boundaries. One day ended, another began. But hidden behind this cycle was the haunting question: was there ever a first day, the one that began all others? They told stories of gods who struck the drum of existence, of cosmic eggs that cracked open to let time pour out, of serpents coiled around the universe whose uncoiling measured eternity. Through myth, they tried to capture the ineffable, the moment something began when there had been nothing at all. But myth could not tame the vastness of the question. As civilizations grew, so did the tools they crafted to mark the march of moments. A shadow stretching across a sundial, sand slipping grain by grain through a glass vessel, water dripping rhythmically from one vessel into another. Each device was an attempt to trap the invisible. These instruments were not only tools but metaphors. The ancients realized that time was not just what the heavens displayed, but what governed every heartbeat, every breath, every fleeting chance. Still, the great question lingered: did time exist before these cycles? Was it born with the stars, or was it always waiting, patient, invisible, eternal? Modern science would eventually pose the question differently. Today, we might speak of singularities, of the Big Bang, of a universe that expanded from a point smaller than imagination can grasp. In that infinitesimal instant, time itself unfurled, inseparable from space, flowing outward as galaxies were seeded. Yet even with equations, with models that map those primal instants, the same mystery arises: what came before? Can there even be a before when time itself was just beginning? The human mind, built to think in terms of cause and effect, struggles against the paradox. Our words fail, our images collapse, and yet the question grips us tighter. The first tick of time is both the simplest and most impossible thing to imagine. The emotional weight of this mystery is profound. To think of a beginning is to think also of an end. If time has a first tick, might it also have a last? The haunting silence of creation echoes forward into the haunting silence of extinction. The same pulse that brought galaxies into being carries them toward their eventual collapse. And yet, within this sweeping current, life emerged, and with it, beings capable of asking why. That first beat of time set the stage not only for stars and worlds but for memory, for history, for every story ever told. In a sense, the very act of wondering about the origin of time is itself a continuation of that first echo, reverberating through conscious minds. Imagine for a moment standing at the edge of that beginning, looking into the void before it all. What would it mean to be present at the birth of duration itself? The first second would not resemble any second we know. It would not tick on a clock or chime like a bell. It would be the raw potential for change, for motion, for existence to have structure. From this perspective, time is not merely a backdrop but the central thread weaving reality together. Without it, nothing can unfold, nothing can grow, nothing can end. It is both the stage and the script, the invisible rhythm to which the cosmos dances. And so the first tick of time remains both a scientific riddle and a poetic mystery. It challenges us to imagine beyond what imagination was built for, to think not just of things happening but of the possibility of happening itself. Every theory, every story, every instrument humanity has built is a lantern held up against that primordial darkness. None of them fully illuminate it, but all of them remind us that we are part of the same current. We ride upon the same pulse that once stirred silence into motion, that transformed nothing into something. And perhaps that is the truest gift of the first tick of time. It did not only create the universe, it created the possibility of wonder itself. Time is one of those ideas so ordinary we barely notice it, yet so elusive it slips through every attempt to pin it down. Is it something woven into the fabric of the cosmos, an eternal river flowing whether or not anyone is there to measure it? Or is it something we invented, a clever trick of human minds desperate to impose order on the chaos of existence? This question is not a trivial one. It is the very heart of philosophy, science, and human experience. From the earliest myths to the equations of modern physics, we have been caught in this tension: time as invention versus time as reality. And each side pulls us toward radically different visions of what existence really means. To call time a human invention is to admit that much of what we think of as time is a system of measurement. Days, hours, minutes, seconds, these are divisions, not things. We cut the sky into slices by watching shadows crawl across stone markers. We invented calendars to track harvests, the slow shifting of stars, the cycle of birth and decay. These tools are immensely practical. They allow us to gather, to build civilizations, to plan for futures that do not yet exist. But what if the units are just that, units? A second is nothing more than a convention agreed upon, a rhythm chosen. The danger is that we mistake the map for the territory, the clock for time itself. Perhaps there is no time beyond these rhythms, just change, and our desperate need to name and order that change. Yet to call time only an invention feels unsatisfying. Something is undeniably happening out there, something beyond our calendars and clocks. The stars burn, galaxies collide, children grow old, and rivers carve valleys through stone. Even if no human mind were alive to mark these shifts, they would still unfold. That points to something deeper, something real. The philosopher Augustine once confessed that he knew what time was until someone asked him to explain it. His paradox still holds. We feel time's grip in every breath, yet when we try to capture it, it vanishes like smoke. If time is real, it may be the most fundamental reality of all, the very condition for anything else to exist. Without it, how could there be movement? How could there be cause and effect? This tension between invention and reality has shaped entire civilizations. In some ancient traditions, time was seen as circular, endlessly looping like the cycles of the seasons or the wheel of life. In others, time was imagined as linear, stretching from a definite beginning toward some distant end. These visions were not idle metaphors. They determined how cultures thought about destiny, morality, even death. To see time as cyclical is to see life as renewal, suffering as something that will come around again, salvation as an eternal return. To see it as linear is to see life as a one-way journey, each moment unique and unrepeatable, leading to an ultimate conclusion. Both frameworks are ways of grappling with the same haunting uncertainty. Is time something out there, or just a lens through which we see? Philosophy sharpened this question with relentless clarity. Plato described time as a moving image of eternity, a shadow cast by something beyond change. Aristotle, in contrast, defined time as the measure of motion, inseparable from the movements of bodies. Centuries later, Kant argued that time was not external at all but a structure of the human mind, a way our consciousness organizes experience. If Kant was right, then time exists only within us, and the cosmos outside is timeless. This is a terrifying thought. It suggests that everything we know, from the rising of the sun to the passing of years, is not out there but a construction inside our skulls. Science, too, has wrestled with this divide. Newton described time as absolute, flowing evenly everywhere like a universal river. For him, time was real, external, and objective. Einstein shattered this certainty, showing that time bends, stretches, and slows depending on speed and gravity. Suddenly, time was no longer a single universal river but countless streams flowing differently for every observer. Still, neither Newton nor Einstein could erase the deeper question: are they describing reality itself, or just our models for making sense of it? The debate remains alive in modern physics. Some theories suggest that time might be emergent, not fundamental, a byproduct of deeper laws that themselves exist outside of time. The emotional pull of this debate is as strong as the intellectual one. To believe time is real is to believe we are at its mercy. Every tick of the clock carries us closer to endings we cannot avoid: youth fading, civilizations crumbling, stars burning out. Time becomes a prison, a relentless tide against which nothing can stand. But to believe time is only an invention, a framework of perception, is equally unsettling. If time is not real, what does that mean for our memories, our futures, our sense of identity? Are we living in an illusion, clinging to a phantom structure that does not exist beyond our thoughts? This is where mystery grips the heart most tightly. If time is an invention, then perhaps it can be transcended. Mystics and philosophers have long dreamed of stepping outside time, into a realm of eternity where past, present, and future dissolve into a single presence. But if time is a cosmic reality, then it is not something to escape, but something to endure, to accept as the deepest truth of existence. The labyrinth of time then becomes not an illusion to overcome but a path we must walk, knowing there is no way out. The paradox is inescapable. Every human life is built on the rhythms of time, yet none of us can say with certainty whether time is the stage upon which we act or merely the stage set we have painted around ourselves. The question itself is a kind of labyrinth, one with no clear exit, only deeper corridors of wonder and confusion. And perhaps that is the essence of time's power. It forces us to live suspended between two possibilities, each breathtaking and terrifying in its own way. Either time is the most real thing we will ever encounter, or it is the grandest illusion we have ever invented. The truth may lie in the shadows between them, where invention and reality are not enemies but two faces of the same mystery. The labyrinth of clocks begins not in laboratories of precision but in the dust and shadows of ancient civilizations. Long before humanity mastered steel gears or cesium atoms, people looked to the heavens, where time revealed itself through patterns of light. The rising and setting of the sun etched days into memory. The moon's waxing and waning marked months. The steady return of constellations drew the outline of years. Yet these celestial rhythms, though dependable, were vast and impersonal. Humanity yearned to shrink the cosmos into something tangible, something that could sit in the palm of a hand or stand in the center of a city. Thus began the construction of instruments designed to ensnare time itself, clocks, each one a chamber in the labyrinth we have built around the flow of existence. The earliest clocks were shadows. In Egypt, obelisks and sundials became monuments to the passing of light, their long arms casting moving fingers across stone. Each inch of shadow was a measure, each gradual shift a whisper of the hours. These were clocks that worked only under the benevolence of the sky, silent when clouds gathered, helpless when night fell. Still, they represented something astonishing, humanity's attempt to bind the intangible to the tangible, to slice the infinite into measurable intervals. To stand by a sundial was to watch the universe's pulse in real time, to feel a link between cosmic vastness and human daily life. From shadow to sand, time slipped further into human grasp. The hourglass became a powerful symbol, a simple device of two bulbs and a narrow throat, yet haunting in its symbolism. The steady fall of grains was like watching existence dissolve, second by second, into the abyss of the past. Unlike the sundial, it needed no sun, no stars, only gravity's pull. But its limitation was cruel. Once emptied, it demanded reversal, a reset. In its turning, it reminded humans that while measurement could be cyclical, life was not. Every grain gone was a moment lost, unrecoverable even as the glass flipped. Water too became a vessel for time. The clepsydra, or water clock, dripped patiently in temples and courts, each drop marking the passage of authority and ritual. These devices brought time into the courtroom, into the governance of people's affairs, measuring speeches and trials. Time was no longer just a celestial rhythm or a natural cycle, it was a civic force, one that shaped laws and justice. The labyrinth of clocks deepened, and with each new turn, humanity fell further under time's governance. Then came the ticking of gears, the music of precision. In medieval Europe, great clock towers rose above cities, their bells tolling across streets to order the lives of thousands. For the first time, time became communal, synchronized, inescapable. No longer was it something one observed passively, it was imposed, structured, standardized. The clanging bells announced work, rest, prayer, obligation. The labyrinth closed in tighter, turning the invisible into audible commands. In a sense, the invention of mechanical clocks marked the domestication of time itself. What had once been the vast rhythm of stars became a rigid grid into which human life was forced. Yet the labyrinth had deeper chambers still. With the rise of pendulum clocks in the 17th century, accuracy reached a level that astonished the world. Galileo's insight that pendulums swung in steady rhythm gave rise to devices that could measure seconds with near-perfect consistency. Ships sailed more safely with marine chronometers guiding their navigation. Empires expanded on the back of precise timekeeping, as trade routes and armies marched in lockstep with ticking gears. Time had become power. To command it was to command the world. But human ambition did not stop. The labyrinth grew more intricate as we reached into realms unseen by the naked eye. The invention of the quartz clock in the 20th century brought a new kind of reliability, one born not of shadows or swinging pendulums but of vibrating crystals. Suddenly, the heartbeat of time was measured in millions of oscillations per second. The ancient sands of hourglasses and dripping water were left behind, replaced by an invisible tremor deep within matter itself. Then came the atomic clock, time measured by the oscillations of cesium atoms, so precise that it loses only a single second over millions of years. In this chamber of the labyrinth, humanity achieved something remarkable, the ability to define the second not by stars, not by gears, not by glass or pendulums, but by the very vibrations of the universe's fundamental building blocks. Time was no longer just a concept, it had been bound, refined, captured in an almost absolute way. Global positioning satellites now rely on these atomic pulses, meaning our maps, our movements, even our very sense of place depend on the relentless accuracy of invisible clocks orbiting above. And yet, even as we weave this labyrinth tighter, questions echo through its halls. Have we truly captured time, or only built mirrors that reflect our own obsession with control? The sundial measures shadows, the hourglass measures gravity, the quartz clock measures vibrations, the atomic clock measures quantum oscillations, but do any of these measure time itself? Or are they simply measuring change, disguising motion as duration, giving names to something that slips forever beyond our grasp? The labyrinth of clocks is both triumph and trap. On one hand, it represents humanity's brilliance, our determination to pull order out of chaos, to make the intangible tangible. On the other, it shows our vulnerability, our need to cage what cannot be caged, to define what refuses to be defined. Clocks rule our days, dictating when we wake, when we work, when we rest, when we die. And yet, no matter how finely tuned, no matter how accurate, they cannot tell us what time is. They can only whisper how much of it has passed. The labyrinth still stretches onward, deeper than any civilization can walk. With every advance, we gain precision, but we also deepen the mystery. Behind the ticking of every clock lies the same haunting silence, the silence of the first tick, the silence of a universe that may not run on clocks at all. Perhaps in the end, our instruments do not measure time, but our shadows against eternity. Time in the language of physics is a story of revolutions, each one dismantling the certainty of the last. For centuries, time was thought of as a universal stage, absolute, unchanging, eternal. Isaac Newton imagined it flowing like a perfectly straight river, steady and indifferent, the same everywhere in the cosmos. For him, time was an invisible backdrop, something that ticked forward relentlessly, even if no events filled its current. This conception was comforting in its clarity. It gave scientists the foundation to measure motion, to predict the paths of planets, to imagine the universe as a vast machine wound by divine hands. Yet, even as this framework dominated, cracks began to appear in its smooth surface, and whispers of a stranger truth emerged. The first great rupture came with Albert Einstein. With the theory of relativity, time was dethroned from its position as an absolute ruler. It was no longer an independent river flowing in isolation but a thread woven inseparably into the fabric of space. Together, space and time formed a single entity, spacetime. This revelation was not just a mathematical trick, it was a reimagining of reality itself. Suddenly, time could bend and warp. It could stretch or contract depending on the speed of an observer or the pull of gravity. The universe was no longer governed by the beat of a single, objective clock. Each observer carried their own time, and no two experiences of duration were guaranteed to align. The imagery this creates is almost cinematic. Imagine two twins, one remains on Earth while the other rockets across the stars at near the speed of light. When they meet again, the traveler has aged only a fraction compared to the sibling left behind. The very idea that time could move at different rates depending on motion shakes the foundations of our common sense. It means there is no universal now, no cosmic heartbeat that binds all events together. The present is not shared equally, it is stitched differently into the fabric of each perspective. Relativity also revealed the strange intimacy between time and gravity. Near massive bodies, like black holes, time slows dramatically. To an observer falling toward such a cosmic abyss, moments might feel normal, but to someone watching from afar, the fall appears frozen, stretched endlessly at the edge of the event horizon. Time, once thought to be uniform, is shown to be malleable, elastic, a property of geometry itself. The ticking of a clock depends not only on its mechanism but on its position in the universe. Every clock is tied to the curvature of spacetime, and so, every measure of time is local, relative, and ultimately personal. Yet Einstein's revolution was not the final word. The rise of quantum mechanics complicated the picture further. In the quantum realm, time seems to behave differently, less like a river and more like a flickering set of possibilities. Particles can exist in superpositions, their states undefined until measured. In such a world, what does it mean to speak of a moment? Is there a clear before and after, or is time itself smeared into probabilities? Some physicists argue that time, at its deepest level, may not even exist. Instead, what we experience as time could be an emergent phenomenon, arising only when larger systems interact, much like temperature emerges from the motions of countless molecules. This collision of relativity and quantum mechanics creates a paradoxical labyrinth. On the grand scales of stars and galaxies, Einstein's spacetime works perfectly, predicting orbits, collisions, and the bending of light. On the microscopic scales of atoms and particles, quantum laws reign supreme, where uncertainty and chance dominate. But when physicists try to merge the two realms, when they attempt to describe the universe as a whole, time becomes one of the first concepts to break down. Does time flow smoothly, as relativity suggests, or does it flicker in discrete intervals, as quantum theory might imply? The language of physics has given us extraordinary power to measure and predict, but it has also left us standing before an abyss of uncertainty. The emotional weight of this is profound. We once thought of time as solid, reliable, unyielding. Now it appears to be fragile, flexible, perhaps even illusory. To say that time is relative is not only to say that clocks run differently, it is to say that our very sense of existence is tethered to perspective. What feels like an eternal second to one may be an entire lifetime to another. Time, in the language of physics, is not one thing but many, a shifting, elusive property that refuses to be pinned down by a single definition. And yet, this strangeness is also a source of wonder. It suggests that the universe is far richer than our common-sense perceptions allow. The bending of time near massive objects, the dilation of time at high speeds, the uncertainty of time in quantum fields, all these phenomena hint at a cosmos alive with mysteries. They remind us that what we take for granted in daily life is only a sliver of a deeper reality. The ticking of our watches and the rhythm of our routines are parochial, local, fragile constructs compared to the vast, labyrinthine structure of spacetime. The story of time in physics is therefore not a settled tale but an unfolding drama. Each revolution brings clarity and confusion in equal measure. Newton's absolute time gave us predictability, Einstein's relativity gave us malleability, quantum theory gave us uncertainty. Each step reveals new layers of reality while deepening the mystery at its core. The more we learn, the less certain we become of what time truly is. Perhaps that is the ultimate paradox. The language of physics, designed to clarify, instead opens us to wonder. It forces us to confront a universe in which time is not a universal rhythm but a patchwork of experiences, stitched together by motion, gravity, and perception. It leaves us with a haunting question. If time is not absolute, if it is bent and uncertain, then what is it that carries us from birth to death, from the first tick of creation to the final silence of the cosmos? The arrow of time is one of the most haunting features of existence. We sense it constantly, even if we do not name it. A broken glass never leaps back together. Smoke drifting into the sky never gathers itself back into the candle flame. We age but never grow young again. Memories form, but they never reverse into predictions that rewrite the past. This strange, one-directional flow is the arrow of time, and it points relentlessly forward. Though physics equations at their most fundamental often describe processes that can run both ways, forward or backward, our experience tells us otherwise. We are caught in the current, moving one way, never able to return. Why is the arrow of time so stubbornly aligned with decay, with endings, with irreversibility? The answer, or at least the most widely accepted one, lies in the second law of thermodynamics. Entropy always increases. Entropy is often described as disorder, but more accurately it is a measure of the number of ways a system can be arranged. A neat, ordered state has fewer possible arrangements, while a messy, spread-out state has vastly more. Imagine a deck of cards. Perfectly stacked by suit and rank, the arrangement is rare and precise. Shuffle them once, twice, 100 times, and the likelihood of returning to perfect order becomes nearly impossible. The universe, like the deck, moves toward the states that are most probable, the states with the greatest number of arrangements, disorder. Entropy rises, and with it, time's arrow points forward. This idea paints an unsettling picture. The melting of ice, the fading of memory, the collapse of stars, all these are not accidents but inevitabilities. The second law is merciless, and it gives time its direction. Without it, there would be no difference between past and future, no reason a shattered cup could not reassemble, no reason we could not remember what has yet to happen. But entropy has bound us. The arrow is drawn, and it pierces every moment of our lives. Cinematic images help us grasp this truth. Picture a candle flame flickering in the dark, wax pooling at its base. The flame gives heat, light, comfort, but at the same time, it consumes. The wax that drips away, the smoke that curls upward, are entropy's signature. Or picture a once bright star collapsing into a cold white dwarf, its radiant energy scattered irretrievably across the cosmos. These images are both beautiful and devastating, capturing the paradox of time. Its forward march is what makes change possible, but it is also what ensures that all things end. And yet, the arrow of time is not just cosmic, it is intimate. It beats within our veins. Our bodies are machines that fight against entropy, temporarily holding order through the constant flow of energy. Every breath, every heartbeat, every meal consumed is a battle against decay. But the war is already decided. Over years, cells degrade, DNA mutates, muscles weaken. The arrow pierces us as surely as it pierces stars. Mortality is entropy written in flesh. The forward flow of time is not just an abstract principle but a constant presence in our most personal fears. But here lies a mystery. Why was the universe ever ordered enough for entropy to increase? If entropy is always rising, then at the beginning, it must have been astonishingly low. The cosmos began in an improbably ordered state, one that allowed the arrow of time to exist at all. Why? Why should the universe begin in such unlikely conditions? Scientists cannot yet answer. The initial low-entropy state remains one of the greatest puzzles of cosmology. Without it, there would be no arrow, no irreversible flow, no memory, no life. The question lingers like a shadow behind all our equations. Why did the cosmos begin in order, only to unravel into disorder? Some philosophers suggest that the arrow of time is as much psychological as physical. We remember the past but not the future. We perceive change in one direction. Our minds build continuity from memory, stitching together a narrative that flows forward. Could it be that the arrow is a construct of consciousness, not reality itself? If so, perhaps time does not really flow, perhaps it simply is. The past, present, and future may all exist together, like pages in a book, while we experience them sequentially. The arrow may be our illusion, a byproduct of how our brains process information. And yet, the emotional weight of the arrow is undeniable. It gives urgency to life. Without it, nothing would matter, victories would dissolve as quickly as failures, joy would blur instantly with sorrow, beginnings would collapse into endings. The forward march of time is painful, but it also gives meaning. A flower is beautiful precisely because it withers. A moment is precious because it cannot be retrieved. The arrow of time is both our doom and our gift. Still, the haunting question refuses to leave us. Could the arrow bend backward? Science fiction thrives on this possibility. Stories of reversed entropy, of timelines that fold back on themselves, of futures that rewrite pasts, all capture our imagination. Yet physics offers no evidence such reversals can occur. The equations might allow them, but the universe seems unwilling. Once glass is broken, once stars explode, once lives are lived, the path is sealed. The arrow continues forward, unwavering. And so, we live suspended in its current, caught between awe and dread. The arrow of time is relentless, merciless, but also strangely tender. It gives us the rhythm of life, the chance to grow, to change, to love, to lose. Its direction is what allows history to exist, stories to unfold, experiences to be remembered. Without the arrow, there would be no narrative, no journey, no meaning. In the end, perhaps the arrow of time is not just a scientific concept but a mirror of the human condition. It reminds us of impermanence and demands that we treasure the fleeting. It binds us to mortality but also to meaning. And as entropy rises, as stars collapse and moments fade, we are left with the haunting, unanswered question. If the arrow always points forward, what lies at the place where it finally stops? The heat death of the universe is one of the most chilling and profound predictions of modern cosmology. It is not a violent apocalypse, not an inferno of collapsing stars or a cataclysmic collision of galaxies, but a whispering fade into silence. It is the slow extinguishing of everything, a long twilight where the cosmos does not end in fire but in frost. To understand it, we must follow the arrow of time to its ultimate consequence, for if entropy always increases, then eventually the universe must reach a state where no more useful energy remains. No structure can form, no flame can burn, no life can persist. The heat death is entropy's final triumph, the complete leveling of all differences, the total flattening of all contrasts that make existence possible. Imagine the universe as a vast stage upon which dramas unfold. Stars ignite, galaxies collide, black holes consume. But all these processes require gradients, differences in temperature, in energy, in density. It is those differences that fuel motion, that allow suns to shine and planets to orbit. Entropy slowly erases those gradients. Heat flows from hot to cold, matter spreads out, energy disperses. And when everything is uniform, when all gradients are gone, the stage remains but the drama is over. The universe is still there, but it is silent, still, inert. Scientists call this the state of thermodynamic equilibrium. It is a condition where energy is perfectly distributed, where no pocket of difference exists to drive change. Picture a cup of hot coffee in a cold room. At first, heat flows out, steam rises, the drink cools. But eventually, the coffee and the room reach the same temperature, and the flow stops. Nothing changes anymore. The heat death of the universe is this process on a cosmic scale. Every star, every particle, every photon gradually settling into balance until no further change is possible. But the word death is not chosen lightly. For this state is lifeless. Life, by its very nature, requires imbalance, a flow of energy, a gradient to exploit. Plants thrive on the difference between sunlight and shadow, animals on the energy locked in food, minds on the chemical currents coursing through their cells. When all gradients dissolve, when the universe becomes a smooth, lukewarm bath of particles and radiation, life can no longer exist. The last star will burn out, the last black hole will evaporate, and the last spark of consciousness will fade into silence. Cinematic imagination helps us feel the weight of this idea. Picture the universe as an ocean whose waves gradually flatten until the surface is a mirror, endless and still. No tides, no storms, no ripples, just infinite calm. At first, the image is peaceful, even beautiful. But linger on it long enough and the beauty curdles into dread. For it is not the peace of fulfillment, but the peace of absence, the silence of an extinguished song. And yet, the heat death is not an imminent threat. It lies in a future so distant that human imagination strains to grasp it. We measure time in days and years, perhaps centuries. The universe measures in trillions upon trillions of years. Stars like our sun will shine for billions more before dying, galaxies will dance and collide for eons, and black holes themselves will take unimaginable spans to evaporate through Hawking radiation. The heat death is not tomorrow, not next age, not even within the lifespan of galaxies. It is the conclusion of time on scales where numbers almost lose meaning. Still, the thought unsettles. For if the universe truly ends this way, then everything, every story, every achievement, every civilization, fades into insignificance. The universe does not remember. It simply disperses, equalizes, dissolves. From the perspective of entropy, all the richness of history is temporary pattern, destined to be erased. It is this erasure that gives the heat death its haunting quality, the suggestion that the cosmos itself carries no ultimate memory of us. And yet, perhaps there is another way to view it. If the universe is destined to end not with a violent crash but with a gentle fade, then our place within it becomes more meaningful, not less. Against the backdrop of ultimate silence, the fact that we exist now, in this brief flickering window of complexity, becomes extraordinary. The stars are burning, galaxies are forming, life is thinking. This moment is fragile, temporary, but it is real. To live in the age before heat death is to live in the rarest of all epochs, when the universe still sings. Philosophers have wrestled with the meaning of such an ending. Does it strip life of purpose, knowing all will dissolve? Or does it grant urgency, reminding us that meaning is something we create in the fleeting here and now? Perhaps the answer lies in how we respond to impermanence. Just as a flower is precious because it withers, the universe may be precious because it will one day fade. The heat death is not just a scientific theory but a meditation on impermanence written in the stars. It is entropy's final whisper, the arrow of time's last destination. And whether we face it with dread or with awe, it forces us to confront the deepest of questions. Is meaning found in permanence, or in the fragile beauty of what can never last? The arrow of time is one of the most familiar yet baffling mysteries in science. Every human being feels its pull, from the rising sun that always comes after the night, to the faces in the mirror that grow older, never younger. We know, instinctively and intimately, that time flows in one direction, from past to future, from memory to anticipation. But physics, when stripped to its barest equations, does not seem to agree. The deep laws of nature, written in the language of mathematics, are symmetrical. They work the same whether time flows forward or backward. If the equations allow a cup to fall and shatter, they also allow the shards to leap up and reassemble themselves into a cup. Yet in the world we inhabit, the cup never unbreaks. Entropy increases, disorder grows, and the arrow of time points relentlessly forward. Why? This tension between perception and equation has haunted thinkers for centuries. On one hand, Our daily experience insists that the past is behind us and the future lies ahead. On the other hand, the universe on its most fundamental level appears indifferent to such distinctions. The puzzle is not just scientific, but existential. Why does time feel like a one-way street when the foundations of reality suggest it could run in both directions? To grasp this paradox is to stand at the edge of one of the deepest labyrinths in science. Entropy, once again, seems to hold the key. As disorder spreads, as differences dissolve into equilibrium, the universe itself creates a temporal gradient. Imagine a pristine egg cracking and scrambling into a pan. There is nothing in the physics of molecules that forbids the reverse, scrambled yolk and white gathering neatly back into a shell, but the probability is vanishingly small. In this sense, the arrow of time may emerge not from fundamental laws, but from statistical inevitability. The universe began in an extraordinarily low entropy state, and ever since, entropy has been climbing, pushing time forward like a river flowing downhill. We do not perceive time's arrow because of the equations, but because of the boundary conditions set at the universe's birth. And yet, this explanation raises more mysteries than it resolves. Why did the universe begin in such an improbably ordered state? Why should the cosmos start off with such low entropy when chaos is far more likely? Was it chance, necessity, or something deeper? Every explanation seems to push the question further back, to some deeper riddle we cannot yet see. For some, the arrow of time is evidence of a cosmic fine-tuning, a delicate balance written into the fabric of reality. For others, it hints at hidden dimensions or unseen structures beyond our current comprehension. The emotional impact of this paradox is profound. To think of time as an illusion, a construct born from entropy, is to question the most intimate aspects of being human. Memory itself is tied to the arrow of time. We remember the past, but not the future. Why? Because the act of remembering requires energy, organization, and the storage of information, processes that increase entropy. In this sense, memory and forgetting are woven into the very same fabric that drives stars to burn and galaxies to spread apart. Our sense of yesterday and tomorrow is not a separate phenomenon, but a consequence of the universe's drift toward disorder. Cinematic imagery helps us capture the strangeness of this truth. Imagine walking through a corridor of mirrors, where every reflection shows a different version of yourself, some older, some younger, some distorted. The corridor seems endless, and yet you are pulled forward, unable to step back into the reflection of youth. That corridor is time, a hole we must traverse in one direction only. The mirrors tease us with what the equations suggest is possible, but the flow is irreversible. The arrow of time also reveals a haunting asymmetry in human existence. We can recall our childhood, relive its scents and sounds in memory, but we cannot step into the future with the same clarity. Our lives are narratives unspooling forward, written in ink that does not erase. Regret, loss, and longing are born from this one-way motion. Yet so are hope, anticipation, and growth. Without the arrow of time, there would be no story, no transformation, no meaning in change. If time ran backward as easily as forward, existence would collapse into stasis, a symmetry too perfect to allow life. And so the paradox deepens. Time's arrow is not found in the equations, but in us, in memory, in death, in the flow of entropy that shapes everything we know. To ask why time flows forward is to ask why the universe began in such a strange state, and why it continues to carry us forward on its invisible current. Science may one day decode the mathematics, but the human heart will still wrestle with the emotional truth. We are creatures bound to an arrow we cannot turn around. The arrow of time remains both a riddle and a compass. It tells us where we are going, but not why. It sets the stage for every story, but never explains its beginning. It is the force that ensures cups shatter, stars collapse, and lives grow old, yet it leaves us wondering, is the arrow truly a law of nature, or only a shadow cast by something even deeper, hidden in the labyrinth of existence? The mystery pulls us forward, just as time itself does, into a future we cannot yet see but are destined to meet. Deep within the equations of Einstein's general relativity lies one of the most haunting predictions in all of physics, the existence of closed time-like curves, paths through spacetime that loop back upon themselves. If such loops are real, they would allow a traveler to journey forward in time only to return to the very point from which they began, trapped in a cosmic circle. To step onto such a path would be to step into eternity, where beginnings and endings dissolve, and causality itself begins to fray. The thought is both intoxicating and terrifying. Could the universe itself contain hidden corridors where time does not march forward but folds back, swallowing its own tail? Visualize spacetime as a vast, pliable fabric stretched across infinity. Normally, events unfold along straight lines through this fabric, past behind, future ahead. But under certain extreme conditions, relativity suggests, the fabric could twist, bend, and knot upon itself. Around rotating black holes, for instance, equations reveal that spacetime might be dragged into whirling spirals, creating regions where the flow of time loops back. Here, cause and effect blur. A traveler might encounter their own shadow, their own echo, perhaps even their own self. The mind reels at the paradox. Can you be both the author and the consequence of your own existence? The implications for causality are staggering. If you return to your own past, could you alter it? The paradox of the grandfather problem illustrates the tension. If you travel back and prevent your ancestors from meeting, how could you exist in the first place to undertake the journey? Physics wrestles with these contradictions. Some theorists propose that the universe enforces a kind of consistency principle. You cannot change the past, only fulfill it. In this view, time loops are self-consistent stories, where every action you take was already written into history. The past bends but does not break. Yet others imagine branching timelines, multiverse in which each alteration births a new strand of reality. In such a cosmos, time loops might not trap us but instead splinter existence into infinite variations. Philosophically, closed time-like curves are like riddles whispered by the universe. If they exist, they suggest that time may not be a linear corridor but a labyrinth, filled with doors that lead back to themselves. What then becomes of free will, of choice, of narrative? To live in a loop is to be both prisoner and participant in a play that repeats forever. Yet there is a strange comfort too. In a loop, nothing is ever truly lost. Every moment returns, eternally, like notes in a song played on repeat. Perhaps such loops embody Nietzsche's idea of the eternal recurrence, where every joy and every sorrow must be embraced as if they will return infinitely. And yet, even as mathematics allows for these loops, physics may forbid them. Quantum effects, some argue, might destabilize closed time-like curves before they can form. Hawking himself proposed the chronology protection conjecture, suggesting that the laws of nature prevent paradoxes by disallowing stable time loops altogether. In this interpretation, the universe has safeguards against self-contradiction, preserving causality like a fragile thread. Still, the idea lingers, for the mathematics is stubborn, and the universe has often revealed truths stranger than speculation. To bring the imagery into focus, picture an ancient labyrinth carved into stone, its corridors winding endlessly until some fold back to their beginning. To walk such a labyrinth is to lose the distinction between progress and return. Each step forward may also be a step backward, every path a circle disguised as a line. Closed time-like curves are this labyrinth written not in stone, but in the very geometry of reality. They whisper that time itself may be more intricate than we dare to believe. For us, the emotional weight of such possibilities is immense. If time loops exist, then destiny may not be something ahead of us but something we are already enacting, again and again. Our victories, our regrets, our loves and losses would not fade into the past but re-emerge eternally. Is this heaven, or is it hell? The answer depends on how we face the prospect of living every moment not once, but forever. In the end, closed time-like curves remain a tantalizing intersection of science and philosophy, of mathematics and myth. They force us to question the solidity of time's arrow, the integrity of cause and effect, the very meaning of change. Whether they are mathematical curiosities or hidden features of the cosmos, they invite us into the labyrinth, daring us to confront the possibility that time is not a line but a circle, and that within its loops we might one day meet ourselves, face to face. Beyond the labyrinth of time loops lies a darker, stranger frontier, the hidden dimensions of time itself. For centuries, we have assumed that time is singular, a lone arrow threading the fabric of existence. Past, present, future, one line, one flow. Yet modern theories in physics whisper of possibilities far more exotic, that time may not be one-dimensional at all, but woven from multiple threads, each flowing in directions we cannot perceive. Just as early humans once believed the Earth to be flat before discovering the vastness of space, perhaps we now mistake time as linear when in truth it may have depths, layers, and directions invisible to our senses. String theory, one of the most ambitious attempts to unify the laws of nature, suggests that the universe may contain more dimensions than we can directly observe. Space, to us, appears three-dimensional, yet string theory allows for as many as 10 or 11 dimensions curled up in hidden forms, too small for our instruments to detect. What if time, too, is not limited to a single arrow but entwined with these hidden dimensions? Could there be additional temporal directions, perpendicular to the one we experience, waiting silently in the fabric of reality? the very idea strains the imagination. To picture more than one kind of time is to abandon the familiar structure of cause and effect. In our world, event A leads to event B, and never the reverse. But with multiple times, cause and effect could unfold along different axes. An event might be simultaneous in one temporal dimension but sequential in another. The consequence could be realities where the notion of before and after is not absolute but relative, shifting depending on which temporal direction you travel. Such worlds would not merely be foreign, they would be incomprehensible, like colors invisible to the eye. Mathematics, however, gives form to what imagination struggles to hold. Some theoretical models describe two-time physics, where particles trace paths not just through space and one dimension of time, but through multiple temporal coordinates. These models, though speculative, suggest a universe more intricate than we ever suspected, where our familiar arrow of time is just one projection of a larger multidimensional truth. We, bound within a single thread, see only the shadow, never the full tapestry. The emotional weight of this vision is profound. To live in a universe with hidden times is to realize that our experience of reality may be only partial, a sliver of a much grander whole. We feel secure in the march from past to present, but what if countless other flows of time intersect our own, unseen yet real? Might there be beings, phenomena, or even versions of ourselves navigating those hidden currents? The question unsettles because it strips away the illusion of completeness. What we call reality might be no more than a narrow corridor in a vast palace of time. Cinematic imagery helps us grasp the scale of this mystery. Picture a library so immense that it extends beyond sight in every direction. We walk one aisle, reading one sequence of books in order, believing that this is the entirety of the library. But all around us stretch other aisles, other sequences, other stories, existing simultaneously yet beyond our reach. Hidden dimensions of time are these unseen aisles, parallel narratives unfolding along different currents, invisible yet present. We move through one story, unaware of the countless others surrounding us. Philosophers have long speculated on such multiplicities. Ancient mystics spoke of layered realities, where time in the heavens flowed differently than time on earth. Myths of gods stepping outside of time, of eternal realms where cause and consequence dissolve, may be echoes of an intuition humanity has never lost. Modern physics reframes these intuitions in mathematical form, suggesting that what we once called myth may hint at deeper truths. But the possibility of hidden temporal dimensions is not without danger. If they exist, they threaten to unravel the very fabric of causality that gives coherence to our lives. Imagine choices that unfold differently along different temporal axes, realities where every decision branches into outcomes invisible to us but no less real. Free will, identity, even memory would fracture, no longer grounded in a single unbroken thread. In such a universe, who would we be? Travelers lost in a maze of times, uncertain which self was truly ours. Still, the mystery is as awe-inspiring as it is unsettling. To think that time might be layered, multidimensional, is to glimpse the vastness of existence beyond human comprehension. It transforms our everyday experience of clocks and calendars into something almost childlike, a simplified sketch of a masterpiece whose true complexity we have barely begun to suspect. In the end, the hidden dimensions of time remain a frontier of speculation, a place where mathematics, philosophy, and imagination converge. We do not yet know if they are real, or if they will fade like so many dreams of physics. But the very act of asking expands the horizon of what we think possible. Perhaps one day we will find that time is not the narrow river we believe, but a vast delta branching into unseen directions, carrying with it mysteries we cannot yet name. If time is a river, then black holes are its whirlpools, places where the current does not merely flow forward but twists, slows, and perhaps even stops. Nowhere in the cosmos is the nature of time more distorted, more alien, than in the presence of these gravitational giants. A black hole is not merely a collapsed star, it is a wound in spacetime, a region where gravity grows so intense that nothing, not even light, can escape. And yet, what terrifies scientists most is not what falls in, but what happens to time itself at the edge of that abyss. At the event horizon, the invisible boundary surrounding a black hole, time behaves in ways that defy common sense. To an outside observer, an object falling toward the horizon appears to slow, to freeze, never quite crossing the threshold. The last moments stretch into eternity, light stretched into longer and longer wavelengths until it fades from view. But for the falling traveler, time continues normally. They cross the horizon without noticing anything unusual, moving inexorably toward the singularity at the center. Two perspectives, both true, yet irreconcilable. Time itself, it seems, is not absolute but dependent on where you stand. This duality embodies the deepest paradoxes of relativity. Einstein's theory tells us that time is elastic, warping under the weight of mass and energy. The stronger the gravity, the slower time flows. Near a black hole, seconds for you might be centuries for someone watching from afar. In this sense, black holes are natural time machines, though not in the way science fiction dreams. They do not let us leap into the past or skip into the far future at will, but they reveal that time is not a universal drumbeat. It is a flexible rhythm, altered by the curvature of spacetime itself. The singularity at a black hole's heart represents the ultimate breakdown of this rhythm. Here, the equations of physics collapse, predicting a point of infinite density and zero volume. Space and time themselves appear to unravel, and the arrow of time may lose its meaning entirely. Some scientists suspect that within the singularity lies a clue to quantum gravity, the elusive theory that unites Einstein's relativity with the laws of the quantum world. Others wonder if singularities are not points but doorways, gateways to other universes, or perhaps to regions of spacetime where time flows in directions unimaginable to us. The imagery is cinematic and haunting. Picture a clock spiraling toward a black hole, its hands spinning slower and slower until, from our vantage point, they seem to stop. To the clock itself, time ticks on, oblivious to the distortion. Now picture yourself standing near the event horizon, watching galaxies race forward into their futures while your own seconds stretch longer and longer. In a few minutes of your time, whole civilizations could rise and fall elsewhere in the universe. Black holes, then, are not merely astrophysical objects, they are laboratories where the nature of time itself is rewritten. And yet, the paradox of black holes deepens when we consider information. According to quantum theory, information about the state of particles cannot be destroyed. But when matter falls into a black hole, where does that information go? Does it vanish, violating the fundamental laws of physics? Or is it somehow preserved, encoded on the horizon itself like an invisible hologram? This so-called information paradox is not just a question about particles, it is a question about time, memory, and causality. If information can be lost, then the chain of cause and effect that underlies reality is broken. If it is preserved, then black holes may be cosmic vaults, holding the record of everything that has ever fallen in. The emotional resonance of these questions is immense. Black holes represent both the end of time and a possible key to its deepest secrets. They are cosmic tombs, devouring stars and worlds, yet also cosmic archives, storing the whispers of everything they consume. They remind us of our fragility, one step too close, and even time itself abandons us. But they also remind us of our audacity, for we dare to ask what lies within, to peer into a darkness that erases all light. Philosophically, black holes invite us to reconsider the meaning of eternity. For an outside observer, objects falling in never quite arrive, they are frozen in time. In a sense, every black hole in the universe is surrounded by ghostly shells of fallen matter, locked in eternal suspense. If we could see them, we might witness the histories of stars, planets, even civilizations, trapped forever at the edge of nothingness. The thought is as humbling as it is haunting. Time, usually a relentless current, here becomes a frozen lake. And yet, perhaps black holes are not merely ends but beginnings. Some theories suggest that the collapse of one universe may seed another, that singularities might give birth to new expansions of spacetime. If so, then every black hole is a womb as well as a tomb, every death an opening into a new cosmos. Time, in this vision, does not end but transforms, branching into infinite realities we cannot see. In the end, black holes remain our greatest teachers about time. They show us that time is not fixed but pliable, not absolute but relative, not eternal but fragile. They are the mirrors of our ignorance, reflecting back both the limits of our knowledge and the boundless reach of our curiosity. To contemplate them is to stand at the edge of the possible, gazing into a darkness where time itself disappears, daring to wonder what lies beyond. If black holes are the great distorters of time, wormholes are its secret tunnels, passageways carved into the geometry of spacetime that promise shortcuts across the cosmos and perhaps even bridges between different eras. The very name stirs the imagination. A worm burrowing through an apple does not crawl across its surface but tunnels directly through, emerging on the other side far sooner than if it had traveled the long way around. In the same way, a wormhole bends spacetime back upon itself, connecting distant points that would otherwise be separated by vast gulfs of time and space. But unlike the simple metaphor, the reality is stranger, more perilous, and far more mysterious. The concept of wormholes arose naturally from Einstein's equations of general relativity. In 1935, Einstein and Nathan Rosen described what became known as the Einstein-Rosen bridge, a theoretical structure linking two regions of spacetime. It was a startling possibility. Relativity did not merely allow for such tunnels but almost seemed to invite them. Yet these early models were unstable, collapsing faster than anything could cross them. They were tantalizing hints, not highways. Later physicists, building upon the foundation, began to explore whether exotic matter, material with negative energy density, might hold the tunnels open. If such matter exists, it could in theory stabilize a wormhole, creating a traversable passage through which light, information, or even a traveler might pass. The imagery is irresistible. Imagine a spacecraft poised at the mouth of a wormhole, staring into a swirling throat of warped spacetime. Stars beyond appear distorted, stretched like reflections in a funhouse mirror. Entering the tunnel would be like slipping into a cosmic whirlpool, the fabric of reality folding around you. On the other side might lie another galaxy, another epoch, perhaps even another universe entirely. For the traveler, the journey might take seconds. For an outside observer, centuries could pass. Time itself would not merely be bent but rewritten. The possibility of using wormholes as time machines has captivated physicists and philosophers alike. In theory, if one mouth of a wormhole were accelerated to near the speed of light or placed within a strong gravitational field, time would pass differently at each end. Reuniting the two mouths could then create a temporal bridge, allowing a traveler to step not only across distance but across time. The paradoxes that emerge are the stuff of legend. Could someone journey back and alter the past? Would the universe allow such contradictions, or would it conspire to preserve consistency? Stephen Hawking, wary of paradoxes, suggested that some form of chronology protection might prevent wormholes from functioning as time machines. Quantum effects, he argued, might destabilize the tunnels the instant they threatened causality. Yet the equations themselves refuse to close the door entirely. Philosophically, wormholes embody humanity's twin longings, the desire to escape the prison of distance and the desire to escape the prison of time. For as long as we have gazed at the stars, we have wondered what lies beyond reach, what lies beyond the horizon of our lives. Wormholes seem to whisper that there are hidden doors, secret passages woven into the fabric of reality itself. Whether or not they exist, they stir our sense of wonder and feed the mythic imagination. They are the modern equivalent of ancient portals and sacred thresholds, gateways between worlds. But the dangers are as profound as the promises. A traversable wormhole, if such a thing could be engineered, might be catastrophically unstable. Even the smallest disturbance could cause it to collapse, crushing or scattering whatever attempted to cross. The exotic matter required to stabilize it remains purely hypothetical, its properties bordering on the impossible. And even if such matter could be harnessed, the engineering challenges dwarf anything humanity has ever attempted. To create a wormhole is to sculpt spacetime itself, to wield forces greater than those of stars. The risks may be insurmountable, the dream forever beyond reach. Still, the fascination persists because wormholes are more than scientific curiosities, they are symbols. They remind us that reality might not be confined to the visible, that hidden architectures of time and space may exist beyond our perception. In art, literature, and cinema, wormholes embody the human urge to transcend limits, to leap across the impossible, to refuse the tyranny of distance and time. They are not just tunnels through space, they are metaphors for possibility, for the unseen connections that might bind the cosmos together. To contemplate wormholes is to walk the edge of science and philosophy, between mathematics and myth. Whether they are real, or forever confined to equations, they show us that time itself may be more flexible, more intricate, than we dare to imagine. They suggest that the universe may contain not just straight corridors of causality but hidden doorways where the rules bend, where the story twists, where the impossible becomes, if only for an instant, conceivable. In the end, wormholes leave us with more questions than answers. Are they nature's hidden shortcuts, awaiting discovery? Or are they mirages conjured by equations, forever out of reach? Could they be the key to mastering time, or the doorway to paradox and chaos? We do not know. But the very possibility expands our vision of what time and space might be. They remind us that the cosmos is still filled with mysteries, and that somewhere, perhaps, hidden behind the veil of ordinary perception, there may be tunnels leading to futures, and pasts, we cannot yet fathom. If wormholes beckon us with the promise of tunnels through time, paradoxes confront us with the shadow of those promises, a reminder that bending the laws of causality might fracture reality itself. Time paradoxes are not simply puzzles of science fiction. They are logical landmines hidden inside the equations of physics. The more seriously we consider time travel, the more urgently these paradoxes demand attention. They are the cracks in the mirror, exposing the fragile assumptions upon which our notions of past, present, and future are built. One of the most famous is the grandfather paradox. It begins with a chillingly simple question. If you traveled back in time and prevented your grandfather from meeting your grandmother, would you erase your own existence? And if you never existed, how could you have traveled back in time in the first place? The paradox reveals a vicious loop, a logical impossibility that suggests either time travel cannot exist or that some hidden mechanism prevents such contradictions from occurring. The paradox is not just about family lineage, it is about the consistency of the universe itself. Could reality allow events that undo their own cause? Another paradox, more subtle but no less haunting, is the bootstrap paradox. Imagine finding a book filled with detailed instructions for building a time machine. You follow the instructions, build the machine, and at some point in your journey through time, you leave the very same book behind in the past. The question then becomes, who wrote the book? The information seems to emerge from nowhere, caught in a loop without origin. It is an object, or a piece of knowledge, that exists eternally, passed back and forth through time without ever being created. Such loops challenge our most basic sense of causality, that every effect must have a cause. These paradoxes slice into the heart of physics. Our equations allow time loops and closed time-like curves, but our intuition recoils. Stephen Hawking famously argued for what he called chronology protection, a principle suggesting that the universe conspires to prevent paradoxes from arising. Quantum fluctuations, he believed, might destabilize time machines the moment they threatened consistency. Others argue for self-consistency. If time travel is possible, then events must unfold in such a way that paradoxes cannot occur. You might travel back in time, but anything you do was always part of history. You could not erase your grandfather, you could only fulfill the past as it always was. In this view, the universe is a seamless tapestry where even time travelers are threads woven into its pattern, unable to unravel it. The implications are profound. If paradoxes are forbidden, then time itself might be less a free-flowing river and more a tightly woven fabric where every event is locked into place. Free will would become an illusion, choice merely the playing out of inevitability. Yet if paradoxes are permitted, then the universe might fracture into multiple timelines, each representing a different outcome. Kill your grandfather, and a new branch of reality emerges, one in which you were never born, while your original timeline continues untouched. This branching view resonates with the many worlds interpretation of quantum mechanics, where every possibility splits into a parallel universe. In such a cosmos, paradoxes are not contradictions but gateways to alternate realities. Cinematic depictions of time paradoxes have captured the imagination precisely because they illuminate the tension between destiny and freedom. Films portray characters caught in loops, haunted by versions of themselves, or trapped in universes where every action echoes endlessly. These stories dramatize our deepest fears and hopes, that we might change fate, or that fate is unchangeable no matter what we do. They force us to ask whether the flow of time is rigid or malleable, whether history is a script or an improvisation. Beyond the intellectual puzzles lies something more personal. Time paradoxes unsettle us because they strike at our identity. We are creatures who tell stories about beginnings and endings, about causes and consequences. A paradox shatters that narrative, suggesting a world where beginnings and endings fold into one another, where cause and effect blur until meaning itself trembles. To live in such a universe would be to live in perpetual uncertainty, where even the past is not fixed and the future bleeds into the present. Some philosophers take paradoxes as evidence that time travel is impossible. Others see them as clues, pointing toward deeper laws not yet understood. Perhaps paradoxes reveal the limits of classical logic, hinting that the universe operates on principles stranger than we can grasp. Or perhaps they reveal the boundaries of human imagination, our minds struggling to comprehend realities that exist outside ordinary experience. Yet the allure remains. Paradoxes, instead of discouraging exploration, heighten the mystery. They remind us that the universe may not be tidy, that its rules may bend and twist in ways that defy our neat categories. They suggest that reality itself may be a labyrinth where logic falters, where the straight corridors of cause and effect dissolve into loops and spirals. In contemplating time paradoxes, we glimpse both the fragility of our understanding and the vastness of what remains unknown. They leave us suspended between awe and dread, torn between the promise of discovery and the threat of contradiction. Like mirrors reflecting endlessly into one another, paradoxes reveal that time is not merely a line to be walked but a whole of illusions, where every step echoes in both directions. They do not give us answers, they force us to confront the possibility that answers may not exist in the form we expect. If paradoxes reveal the fragility of our assumptions about time, then multiverse theories attempt to offer a daring solution, an escape hatch from contradictions by multiplying reality itself. Instead of one single thread of time, there may be countless, branching into endless possibilities, each one as real as the universe we inhabit now. This idea transforms time from a narrow arrow into a sprawling web, a cosmic tree with infinite branches. To entertain such a vision is to step into a realm where every choice, every possibility, every variation of history unfolds in parallel, never erased but eternally preserved. At the heart of this concept lies the many-worlds interpretation of quantum mechanics. Proposed by Hugh Everett in 1957, it suggested that every quantum event splits the universe into multiple outcomes. If an electron can spin up or down, then both possibilities occur, each in its own branch of reality. Scale this up, and every decision, every chance occurrence, creates a new universe. In one world, you turn left instead of right. In another, you miss the train, and your life takes a radically different path. The multiverse, in this view, is an infinite library of lives, with every version of you walking its own aisle. This vision offers an elegant resolution to time paradoxes. If you journey into the past and change it, you do not destroy your own timeline. Instead, you create a new branch of reality, one where your actions take root, while your original world continues unaffected. The paradox dissolves into multiplicity. You can kill your grandfather in one universe while still existing in another. Time travel becomes less about rewriting history and more about stepping into another corridor of possibility. Yet the multiverse is more than a scientific theory, it is a philosophical earthquake. If every possibility is real, then what becomes of meaning? Does choice matter if every outcome is played out somewhere? Are we unique, or are we one version among infinite reflections? The multiverse threatens to flatten significance, to turn individuality into repetition. And yet, paradoxically, it also magnifies existence, suggesting that reality is richer and more abundant than we ever dared to imagine. To live in such a cosmos is to live not at the center of a single narrative but at the intersection of endless ones. Visualize it cinematically, an infinite hall of mirrors, each pane reflecting not only your face but a slightly altered version of you. One smiles while another frowns. One wears different clothes, one carries different scars. The reflections stretch outward forever, each one a life lived, each one a path taken. The multiverse transforms time's labyrinth from a singular maze into a fractal, endlessly branching and curling upon itself, with no center and no edge. Physicists grapple with these ideas because they emerge naturally from the mathematics. The equations of quantum theory do not collapse into a single outcome, they allow for multiple. Some scientists dismiss the multiverse as untestable speculation, a philosophical indulgence. Others argue that it is not merely possible but inevitable, the simplest explanation for quantum strangeness. If quantum mechanics is true, then perhaps the multiverse is unavoidable. And if the multiverse is real, then time itself is not a line but a landscape, a terrain with countless trails. This concept extends beyond quantum physics into cosmology. Some theories of inflation suggest that our universe may be one bubble among countless others, each with its own laws, its own time, its own beginning. In such a scenario, time's labyrinth becomes even vaster, with entire universes sprouting like sparks from an eternal fire. What we call reality may be but one chamber in an infinite palace, and our timeline but one path through its corridors. Philosophically, the multiverse invites us to reconsider fate and freedom. If every possibility is realized, then destiny is both everything and nothing. There is no single path written, yet all paths exist. To some, this robs life of purpose. To others, it is liberating, a promise that no choice is ever wasted, that every dream exists somewhere, that no possibility is ever truly lost. It reframes time as not a tyrant but a canvas, vast enough to hold all variations of being. The emotional resonance of the multiverse is undeniable. It speaks to our longing for second chances, for roads not taken, for lives unlived. It suggests that somewhere, in another world, you made the choice you regret not making. Somewhere, you are happier. Somewhere, you are braver. This idea haunts us because it expands our existence beyond the finite. It is a cosmic echo of our desire to be limitless. Yet the multiverse also raises unsettling questions. If every version of us exists, then which one is truly us? Are we defined by the branch we inhabit, or by the totality of our infinite selves? Does morality shift if every action, both noble and cruel, is guaranteed to exist in some universe? The multiverse complicates not only physics but ethics, identity, and meaning. It forces us to confront the possibility that reality is not singular and that our sense of uniqueness may be an illusion born of limited perspective. In contemplating the multiverse, we confront both hope and terror. Hope, because it suggests endless potential, an abundance of worlds where our dreams live on. Terror, because it dissolves the singular narrative of life into infinite fragments. Like time's labyrinth, the multiverse both expands and disorients, reminding us that the cosmos is far stranger than the human mind can fully grasp. And yet, perhaps that is its greatest gift. To imagine the multiverse is to imagine that reality is more than what we see, that our lives are threads in a tapestry too vast to comprehend. Whether true or not, it invites humility and wonder, asking us to stand at the edge of infinity and peer into the branching corridors of possibility, knowing that somewhere, in the maze of time, countless versions of us are doing the same. If the multiverse stretches reality into infinite branches, then quantum time, the strange, flickering reality at the smallest scales, reminds us that even within a single universe, time may not behave as we expect. On the human level, time feels steady, flowing like a river in one direction. But in the quantum realm, beneath the surface of atoms, time begins to blur, ripple, and at times even disappear. To enter this domain is to step into a theater where causality wavers, events occur without clear order, and the ticking of the cosmic clock seems to falter. At the foundation of quantum mechanics lies uncertainty. Heisenberg's principle tells us we cannot know both a particle's position and momentum with perfect precision. In the same way, quantum events refuse to unfold in strict sequences. Experiments reveal particles that exist in superpositions, occupying multiple states at once until observed. If position and spin can exist in many possibilities, could time itself also split into overlapping possibilities? What does it mean to say that something happened before or after if the sequence itself can blur? Physicists have begun exploring this question, and their discoveries are unsettling. Quantum entanglement shows us that particles separated by vast distances can appear to influence one another instantly, as if information traveled outside of time. More recently, experiments with indefinite causal order suggest that, at the quantum scale, event A can influence event B while B simultaneously influences A. In this ghostly dance, cause and effect become entangled, and time loses its familiar directionality. The arrow of time, so obvious in broken glasses, aging bodies, and decaying stars, may not be fundamental at all, but a large-scale illusion that emerges only when countless quantum events average out. Visualize it as a cinematic scene, a droplet of water falling into a still pond. On the surface we see ripples moving outward in neat circles, like time marching forward. But dive beneath the surface and the water molecules themselves are in ceaseless motion, colliding, vibrating, exchanging energy in all directions at once. The orderly ripples above are just an appearance, a macro pattern emerging from chaos below. Time, perhaps, is like the ripples, not an ultimate reality, but an emergent property rising from the quantum sea. One of the deepest mysteries in physics is why time appears to flow at all. The laws of quantum mechanics are largely time-symmetric. The equations work the same whether time runs forward or backward. Nothing in the mathematics demands a forward arrow. And yet, our experience is unyielding. We remember the past but not the future, we grow older, not younger, we see eggs break but never spontaneously reform. The quantum world challenges us to explain this discrepancy. Is the arrow of time a psychological construct, a byproduct of entropy, or something stranger still? Some researchers propose that time itself may be quantized, made up of indivisible units like the frames of a film reel. If so, then the flow of time is not continuous but a rapid flickering, imperceptible to us, a strobing of reality. Others suggest that time is not fundamental at all, but emergent, rising from entanglement and correlations between quantum states. In this view, time is not the stage upon which reality unfolds but a property created by the play itself. If that is true, then the most basic structure of reality is timeless, a frozen matrix of possibilities where our sense of before and after is woven from correlations, not causes. Philosophically, this reshapes our understanding of existence. If time is emergent, then perhaps our lives are not flowing rivers but patterns crystallized in the quantum fabric. Past, present, and future might coexist, their distinctions no more real than the chapters of a book. We flip the pages one by one, but the entire story already exists. To think of time in this way is both humbling and disorienting. It strips away the comforting illusion of linear progress and replaces it with a vision of reality as a whole, where our journey is not unfolding but already inscribed. The implications ripple outward into cosmology. Black holes, for instance, seem to scramble time, with information paradoxes arising from the clash of quantum mechanics and relativity. Near the singularity, the concept of time may disintegrate entirely. At the beginning of the universe, in the first instant of the Big Bang, time itself may have emerged from a timeless quantum state. In such a picture, asking what happened before the Big Bang may be meaningless, like asking what lies north of the North Pole. Culturally and emotionally, the idea of quantum time feeds our fascination with mystery. It suggests a reality stranger than science fiction, where the order of events is not fixed, where the universe may not even possess a single universal clock. It forces us to imagine lives not as linear journeys but as resonances, entangled patterns unfolding across scales. What we perceive as flow may be the shimmer of deeper structures beyond comprehension. And yet, in this strangeness lies wonder. To glimpse quantum time is to realize that the boundaries of our perception are not the boundaries of reality. The river of time we feel so deeply may be a surface effect of a deeper ocean. Our intuitions, forged at the human scale, falter in the quantum realm, but that faltering is a gift. It reminds us that the universe is not bound to our expectations, that beneath the familiar clockwork may lie something unearthly, something timeless. In the end, quantum time is not merely a puzzle for physicists. It is a mirror held up to our own existence, challenging the way we understand change, memory, and mortality. If time is emergent, then perhaps so are we, patterns in the quantum field, fleeting yet eternal, flickering like shadows on the walls of a deeper reality. If quantum time unsettles the flow of causality, entropy provides the arrow that points us forward. Entropy is often described as disorder, but it is better understood as the measure of how spread out energy becomes, how available options multiply as systems evolve. It is the principle behind why heat flows from hot to cold, why stars burn out, why empires crumble, and why our own lives march inexorably toward aging and decay. Entropy is not merely a law of physics, it is the storyteller of time, giving direction to its arrow, ensuring that yesterday and tomorrow are never the same. At the heart of entropy lies the second law of thermodynamics. In an isolated system, disorder tends to increase. Imagine a pristine wine glass shattering on the floor. The shards scatter into chaos, and no natural process spontaneously reassembles them into their original form. This irreversibility is the mark of entropy, the reason we experience time as a one-way street. The equations of physics may be time-symmetric, but entropy breaks that symmetry, giving the universe a memory of what has happened. Consider the cosmos itself. At the moment of the Big Bang, the universe was in a state of astonishingly low entropy, a highly ordered singularity from which everything expanded. Since then, entropy has been climbing steadily, as stars fuse hydrogen into heavier elements, as galaxies spread apart, as black holes swallow matter and radiation. The universe is a grand machine running down, its order unraveling into disorder. The ultimate fate, if entropy continues unchecked, is the heat death, a cosmos stretched thin, with energy spread so evenly that no work can be done, no structures can form, no life can persist. Time itself, in such a frozen future, would lose meaning, as nothing changes and no new story unfolds. Yet entropy is not merely decay, it is also creation. Without entropy, there would be no arrow of time, no unfolding of history, no possibility for complexity. Stars shine because they burn through order, releasing energy into disorder. Life itself feeds on entropy, converting concentrated energy into heat, metabolizing order into survival. Every heartbeat, every thought, every moment of beauty is purchased at the cost of rising entropy elsewhere. In this sense, entropy is not the enemy of meaning but its foundation. The arrow of time emerges from it, carving the path that allows stories to exist at all. Philosophically, entropy embodies the tension between hope and despair. On one hand, it reminds us of the inevitability of decline, the truth that all things must pass. Empires fall, mountains erode, stars collapse. To live is to walk toward disorder. On the other hand, entropy is the backdrop that makes moments precious. Without the shadow of loss, we would not cherish presence. Without the fragility of order, beauty would not shimmer as brightly. The inevitability of entropy does not erase meaning, it deepens it, turning every fleeting second into something sacred. Cinematically, entropy can be imagined as sand slipping through an hourglass. No matter how tightly you try to hold it, the grains slide away, each one marking a moment that cannot be reclaimed. But look closer, and you realize that the patterns left behind, the small dunes, the shapes carved by the falling sand, are themselves forms of fleeting order created in the process of disorder. This is the paradox of entropy, it destroys, but in its destruction, it sculpts. It erases, yet in erasing, it allows new forms to emerge. Entropy also challenges our understanding of memory and identity. Our memories exist because entropy allows the past to differ from the present. We remember what was because it is distinct from what is. In a perfectly reversible universe, memory would dissolve, identity would have no anchor, and change would be meaningless. Entropy is the painter of history, ensuring that time leaves marks behind. It is what makes forgetting possible and remembering necessary. The cosmic dimension of entropy amplifies its emotional weight. If the universe is destined for heat-death, then every act of creation, every poem, every star born, every galaxy swirling, is a temporary defiance against inevitability. We build, knowing what we build will crumble. We love, knowing that love itself is fleeting. And yet, in that fleetingness lies our humanity. To exist is to burn brightly against the darkness, to embrace impermanence as the very condition of meaning. Some scientists, however, wonder if entropy's story might not be final. Black holes, for instance, complicate the picture. They appear as engines of entropy, swallowing information, yet quantum mechanics suggests that no information is ever truly lost. Hawking radiation hints that black holes may slowly evaporate, releasing fragments of order back into the universe. Could it be that entropy, while always increasing, carries hidden symmetries yet to be understood? Could time's arrow bend in ways we cannot yet imagine? In our personal lives, entropy manifests as the inevitability of aging. The body wears down, cells misfire, systems lose their delicate balance. Yet within this decline is also growth, moments of wisdom, reflections carved by time's passing. Entropy is the silent teacher, reminding us that immortality may not be the goal, that meaning emerges not from permanence but from transience. To contemplate entropy is to feel the weight of inevitability and the spark of defiance. It tells us that nothing lasts, but it also tells us that everything matters. The universe may end in silence, but the music we play along the way reverberates within that silence. Entropy is both the end of the song and the reason we hear it at all. If entropy gives time its arrow, memory gives time its texture. Without memory, the past would dissolve into nothingness, the present would lose its context, and the future would become incomprehensible. Memory is the thread that ties events together, weaving them into a story. It is how we know who we are, where we have come from, and why we long for what lies ahead. But memory is not a flawless archive. It is fragile, mutable, and deeply entangled with the mysteries of time itself. To explore memory is to peer into the labyrinth where biology, physics, and philosophy converge. In the human brain, memory is both astonishing and elusive. Neurons fire in intricate patterns, synapses strengthen or weaken, and networks encode the echoes of our experiences. Yet memory is not simply stored like books on a shelf. Each recall reshapes it. When you remember an event, you do not play back a recording, you reconstruct it, layering fragments into a new version of the past. In doing so, you alter the memory itself, subtly changing its shape. Over time, what we remember drifts away from what actually occurred, blurring into something part truth, part invention. The past is alive, rewritten each time we call upon it. This mutability makes memory inseparable from time's paradoxes. If time is a linear arrow, memory allows us to walk backward along its path, at least in imagination. But if time is more fluid, if past and future coexist in some deeper structure, then memory may be more than imagination. It may be a form of perception, a glimpse into the fabric where past moments still reside. Mystics and philosophers have long suggested that memory is not just a brain function but a resonance with reality's hidden architecture. Could it be that what we call remembering is a faint alignment with the echoes of time itself? Cinematically, memory is a flickering film reel. Images dance across the mind screen, some vivid, others blurred. A childhood laugh, the smell of rain, the sting of a wound, moments preserved in fragments, glowing briefly before dissolving back into darkness. Each reel plays not in order but shuffled, spliced by emotion, stitched by meaning rather than chronology. This fragmentation makes memory feel both reliable and dreamlike, grounding us while also deceiving us. On a cosmic scale, memory resonates with the very laws of physics. The universe, in a sense, remembers through entropy. The broken glass on the floor is a memory of the moment it shattered, encoded in the arrangement of shards. The night sky is a memory of light that has traveled for billions of years, carrying the past of distant galaxies into our present. Black holes, paradoxically, are thought to trap information, raising questions about whether the universe can ever truly forget. Memory is not just a human phenomenon, it is a principle woven into reality itself. Philosophically, memory is the battlefield between identity and time. Who are we without the continuity memory provides? If memories shift and fade, are we the same person we once were? Perhaps identity is not a fixed essence but a river of recollections, flowing and changing. This fragility unsettles us, yet it also deepens our humanity. To be human is to live not in absolute certainty but in stories shaped by remembrance and forgetting. Memory also raises the question of the future. We think of memory as backward-looking, yet the same brain structures that recall the past also imagine what has not yet occurred. In a way, memory and foresight are twins. To remember is to simulate, and to simulate is to anticipate. The past and future live in the same mental circuitry, suggesting that time in the brain is not linear but looped, recursive. When we dream of tomorrow, we are borrowing from yesterday, rearranging fragments into visions of what could be. Emotion amplifies memory's power. We remember what we fear, what we love, what wounds us, and what fills us with awe. The emotional charge of a moment imprints it more deeply, ensuring it becomes part of our narrative. But this too shapes how time is felt. A painful memory can make the past feel ever-present, stretching its shadow across the now. A joyful memory can collapse decades into a heartbeat, bringing the past vividly alive. Memory is not just about chronology, it is about intensity. It distorts time, pulling some moments closer and letting others fade. Cinematically, imagine a vast library where some books glow brightly while others gather dust. We wander through the aisles guided not by order but by the lantern of emotion, stopping at shelves that shine, passing by others that remain dark. This library is our inner map of time, lit unevenly, shaped by what mattered most. It is not an objective archive but a subjective constellation, a star map of the self. At its deepest level, memory forces us to confront mortality. Forgetting is inevitable, even the brightest memories dim. Loved ones fade into shadows, names slip away, histories vanish into silence. This loss terrifies us, yet it also inspires us to preserve memory through writing, art, monuments, and stories. We carve our experiences into the world so that something may endure beyond the frailty of mind. Memory, personal or collective, becomes our rebellion against entropy, the refusal to let time erase everything. And yet, perhaps memory is not meant to be perfect. Its flaws give it beauty. To remember imperfectly is to live creatively, to reinterpret the past in ways that serve the present and prepare us for the future. Memory is not a prison of accuracy but a canvas of meaning. It allows us to carry time within us not as it was, but as it matters. In the end, memory is the human face of time's labyrinth. It binds us to the arrow of entropy, yet it also lets us leap across it, revisiting moments long gone and imagining those yet to come. It reminds us that while we cannot control time, we can shape its story. And in shaping it, we become more than its prisoners, we become its storytellers. If memory is the human face of time, then destiny is its shadow, an idea both feared and longed for, whispered across cultures, religions, and philosophies. To speak of destiny is to ask whether time is fixed, whether the paths of our lives are etched into the labyrinth long before we walk them. Are we moving freely through open corridors, or merely tracing predetermined routes laid out by the architecture of the cosmos? This question lingers like a riddle at the heart of existence, where science and philosophy intersect in uneasy silence. Cinematically, imagine a vast maze seen from above. From that perspective, the walls form patterns that suggest inevitability, only one way to reach the center, only certain paths that connect. But from within, the traveler cannot see the whole design. Every choice feels real, every turn uncertain. To the one inside, life feels open-ended. To the architect who drew the map, it may already be complete. This dual perspective frames the tension between free will and determinism, chaos and fate. In the ancient world, destiny was often envisioned as threads spun by unseen hands. The Greeks spoke of the Moirai, the fates, who wove, measured, and cut the strands of life. Norse mythology described the Norns at the roots of Yggdrasil, binding even the gods to time's design. These myths capture a universal intuition, that behind the randomness of events lies a hidden order, a script beyond human rewriting. Yet these same traditions also preserve the drama of choice, heroes striving against doom, love defying prophecy, defiance carving new meaning even within inevitability. Modern science, in its own way, revives the same debate. Determinism, rooted in classical physics, suggests that if we knew the exact state of every particle, the future could be predicted as easily as the past. Laplace Demon, a thought experiment, imagined a mind vast enough to calculate every detail of the universe, leaving no room for chance or freedom. Yet quantum mechanics shattered this vision, introducing uncertainty at the very foundations of matter. Suddenly, the universe was not a rigid machine but a storm of probabilities. Does this restore free will? Or are we still passengers, only now riding statistical waves instead of fixed rails? Destiny also emerges in chaos theory, where even deterministic systems behave unpredictably. A butterfly's wing may alter a storm half a world away. Small choices ripple into vast consequences, blurring the line between freedom and fate. Perhaps destiny is not a single path but a landscape of branching possibilities, each shaped by initial conditions too subtle to measure. We are neither fully bound nor fully free. Instead, we move through a web where structure and spontaneity intertwine. Philosophically, the notion of destiny raises deep questions about meaning. If everything is predetermined, does effort lose significance? Or is meaning precisely found in how we embrace inevitability? The Stoics believed in accepting fate with dignity, aligning one's will with the flow of the cosmos. Existentialists, by contrast, argued that freedom is real precisely because we must create meaning without guarantees. Between these poles lies a tension that gives human life its intensity. We live as if choices matter, even when shadowed by the suspicion that the labyrinth may already be mapped. Emotionally, destiny resonates because it mirrors our deepest experiences of life. Who has not felt the eerie sense of déjà vu, as though walking a path already taken? Who has not wondered, after a chance encounter or life-altering decision, whether it was coincidence or inevitability? Destiny gives language to these feelings, to the sense that some moments are charged with significance, as if time itself pauses to whisper, "This was meant to be." Whether illusion or truth, this sensation gives life a cinematic quality, transforming randomness into narrative. On a cosmic level, destiny raises profound mysteries about time itself. If all of time exists at once, as the block universe theory suggests, then past, present, and future are equally real. Our lives may be like a film reel, with every frame already in place, while we experience them sequentially. In such a vision, destiny is not imposed but simply the nature of reality. Our journey is the unfolding of what already exists. And yet, subjectively, the future remains unknown, brimming with possibility. We live suspended between two truths, that the road may already exist, and that we must still choose each step. Cinematically, picture two mirrors facing each other, reflecting infinite versions of yourself, one stepping forward, one pausing, one turning back. All possibilities exist, yet you can inhabit only one reflection at a time. This is the paradox of destiny and choice. To live is to commit to a single path through the hall of mirrors, even while suspecting that the others shimmer just out of reach. Ultimately, destiny is not only about control but about relationship, our relationship with time, chance, and meaning. Whether the labyrinth is fixed or fluid, what matters most is how we walk through it. Do we see ourselves as prisoners of fate, or as co-authors of time's unfolding story? Perhaps the truth lies in both, that the structure of the maze exists, but within it, the traveler still carves meaning with every step. In this way, destiny becomes less about prediction and more about interpretation. The past may whisper its patterns, physics may chart its probabilities, myths may weave its images, but the lived experience of destiny is felt in the present, in the weight of our decisions, in the echoes of wonder and regret. It is the labyrinth's final riddle. Even if the map is already drawn, the journey still feels alive, uncertain, and profoundly our own. If destiny is the shadow cast by time, eternity is the horizon where shadows dissolve. To speak of eternity is to step beyond the ticking of clocks and the spiral of galaxies, into a realm where time either stretches infinitely or vanishes altogether. Eternity is not simply endless duration, it is the stillness beyond duration, the silence beyond motion. For some, it is the promise of transcendence. For others, it is the abyss of meaning, a concept too vast for the human mind to hold. And yet, every culture, every philosophy, every science that gazes deeply enough into time eventually collides with this final frontier, what lies beyond the labyrinth of moments we call existence. Cinematically, picture a river flowing endlessly toward a horizon that never arrives. The current carries everything, worlds, stars, memories, destinies, but at the horizon, the river vanishes into light. This is the paradox of eternity. It is both infinite continuation and the absence of continuation, a boundary where imagination itself falters. Our stories, religions, and sciences all attempt to approach this horizon, but none can cross it fully. Religions were the first to give eternity a face. In Christianity, eternity is the timeless kingdom of God, a realm where mortal life dissolves into infinite presence. In Hinduism, eternity is the cycle of rebirths, endless yet aiming toward liberation beyond cycles. Buddhism speaks of nirvana, not an eternal extension of time, but the extinguishing of time-bound existence itself. In Sufi mysticism, eternity is union with the infinite, where the self dissolves into the eternal beloved. Across these traditions, eternity represents both hope and terror, the hope that meaning transcends death, and the terror that individuality may vanish into an incomprehensible vastness. Science too confronts eternity, though often reluctantly. Cosmology asks whether the universe will expand forever, drift into a cold, dark eternity of silence, or collapse into a fiery rebirth. Black holes pose their own eternal enigmas, regions where time appears to freeze at the event horizon, as if eternity has touched the edge of the universe. Quantum physics hints at timeless states, where particles exist in superposition until measured, blurring the line between being in time and being outside of it. The deeper science digs, the more it seems to circle back to questions once reserved for mystics. Is time fundamental, or is eternity the true foundation of reality? Philosophers have long wrestled with the paradox of eternity. For Plato, eternity was the realm of perfect forms, unchanging and pure, contrasted with the shadows of time-bound existence. For Augustine, eternity was not endless time but the eternal now, where past and future collapse into divine simultaneity. In modern thought, eternity often becomes a question of perspective. Perhaps what feels temporal to us is eternal in the structure of the universe, and what feels eternal is only an illusion born of scale. Emotionally, eternity unsettles because it challenges the very core of human identity. We measure life in days and years, in beginnings and endings. To imagine eternity is to imagine living without these markers, stripped of the familiar rhythm of time. Some find comfort in this, an escape from decay and death. Others find dread, envisioning an endless continuation without change, where meaning itself dissolves. The mind, built to navigate finite moments, trembles when it tries to grasp the infinite. Cinematically, eternity can be imagined as a whole of endless mirrors, stretching in both directions. Step forward, and you walk forever, turn back, and forever still awaits. Yet at the same time, eternity can be imagined as a single drop of water, containing the whole ocean in miniature, timeless and complete in itself. This duality, eternity as boundless expansion and eternity as timeless stillness, captures why the concept both dazzles and destabilizes us. In the human experience, we brush against eternity in fleeting moments. The gaze at a night sky filled with stars that burned long before we were born. The timeless hush in the presence of great art or profound love. The sense of déjà vu that collapses past and present into a single instant. These are echoes of eternity, whispers that time is not the whole story, that our lives are framed by something larger. Eternity also reframes our mortality. If time ends at death, eternity becomes the unknown that follows. Does the self dissolve, as materialists suggest, into silence? Or does some aspect of consciousness slip beyond time, touching a realm without decay? Here science and spirituality part ways, yet both recognize the same boundary. Eternity begins where measurement ends. Whether eternity is continuation, dissolution, or transformation remains the ultimate riddle. On a cosmic level, eternity is not merely personal, it is universal. If the universe expands forever, galaxies will drift apart until night becomes utterly dark, stars burn out, and matter decays. This heat death is an eternity of silence. But other theories suggest cyclical universes, where time itself may collapse and restart, giving eternity the face of eternal return. Others yet imagine multiverse, where eternity is not stillness but infinite variation. No single vision satisfies, each is as terrifying as it is awe-inspiring. Ultimately, eternity is not something we can solve. It is something we feel at the edges of thought, in the trembling awe that comes when time's labyrinth opens into vastness. Perhaps eternity is not beyond time but woven into it, glimpsed in moments of stillness when seconds feel infinite. Or perhaps eternity is the silence waiting at the end of all journeys, the horizon where the traveler and the labyrinth vanish together. And yet, in the face of eternity, the fragility of our finite lives becomes more precious. Every moment, every choice, every memory is framed by its rarity. Eternity does not diminish time, it magnifies it. For if eternity is the vast sea, then each moment is a shimmering droplet, fragile and luminous, carrying meaning precisely because it will not last. If eternity is the horizon where time dissolves, consciousness is the vessel that experiences it, the lens through which the labyrinth of moments, destinies, and possibilities becomes vivid and real. Consciousness is not merely awareness, it is the interpreter of time, the architect of memory, the navigator of entropy, and the witness to quantum uncertainty. Through consciousness, the abstract constructs of physics and philosophy are transformed into lived reality, giving shape, texture, and emotion to the otherwise indifferent cosmos. To understand consciousness is to confront one of the deepest mysteries of existence, how subjective experience arises within the vast machinery of the universe. At the biological level, consciousness emerges from the intricate dance of neurons. Billions of nerve cells fire in complex patterns, creating networks that encode perception, thought, and feeling. Yet the process is not merely electrical or chemical, it is also dynamic and recursive. Neurons do not just pass signals, they integrate information, anticipate outcomes, and generate self-reflection. A simple sensory input, a bird landing on a windowsill, does not just register as light and movement, it triggers memory, emotion, expectation, and interpretation. Consciousness folds past, present, and potential future into a cohesive narrative, allowing the mind to navigate the labyrinth of time with coherence and meaning. But consciousness is more than a biological phenomenon, it is also a window into the mysteries of time itself. The subjective experience of time differs dramatically from the objective measurements of clocks. A minute in fear can stretch into an eternity, a day in joy can vanish in a heartbeat. Neurologically, this is influenced by attention, emotion, and memory, yet it also hints at a deeper truth. Time, as experienced, is inseparable from the mind observing it. The flow of seconds, the cadence of hours, the arc of a lifetime, all are filtered, shaped, and colored by consciousness. Time is, in a sense, as much a product of the mind as it is a property of the universe. Quantum physics introduces an even stranger dimension. If time is flexible, if events at the quantum level can occur in overlapping or indefinite sequences, then consciousness may be both observer and participant in shaping reality. The act of observation collapses possibilities into concrete outcomes, suggesting that the mind does not merely passively record time but actively influences how events crystallize. In this sense, consciousness becomes a bridge between the abstract laws of the cosmos and the tangible experience of existence, threading subjective reality into the fabric of objective time. Philosophers have long grappled with the enigma of consciousness. Descartes famously declared, "Cogito, ergo sum." I think, therefore I am, highlighting the self-evident certainty of awareness as the foundation of existence. Eastern traditions offer complementary perspectives. In Vedanta and Buddhism, consciousness is not merely personal but universal, a fundamental essence permeating reality. Modern debates explore whether consciousness is emergent, arising from complexity, or whether it is fundamental, an irreducible aspect of the universe akin to space, time, or energy. Either view has staggering implications. If consciousness is emergent, it underscores the miraculous specificity of life. If fundamental, it suggests that awareness itself is woven into the cosmos, inseparable from time, space, and matter. Emotionally, consciousness is the lens through which awe, fear, love, and curiosity are experienced. It gives color to entropy, weight to memory, and urgency to destiny. Without consciousness, the stars burn silently, black holes devour relentlessly, and wormholes twist through spacetime with no witness. With consciousness, the universe becomes a narrative, each event a scene in the story of existence. Our fears of mortality, our longing for transcendence, our curiosity about hidden dimensions, these are all rooted in the fact that consciousness experiences time, perceives possibilities, and asks questions that may have no answers. Cinematically, consciousness can be imagined as a lighthouse in the storm of time. Waves of events crash on all sides, births, deaths, cosmic collisions, quantum fluctuations, but the mind illuminates a narrow corridor, allowing focus, interpretation, and meaning. Yet consciousness is not static, it expands, contracts, and shifts perspective. In dreams, time dilates and contracts, in deep reflection, moments stretch into lifetimes. Consciousness does not merely observe the labyrinth, it navigates it, shapes it, and, in a sense, constructs it. Memory, entropy, quantum uncertainty, destiny, and eternity all converge within consciousness. Each plays its part in the theater of experience. Memory allows us to trace paths we have walked, entropy gives direction and stakes, quantum mechanics offers uncertainty and multiplicity, destiny poses challenge and purpose, eternity frames the context of the infinite. Consciousness stitches these threads into coherent awareness, transforming raw phenomena into lived reality. In doing so, it becomes both a product of the cosmos and a microcosm of its mysteries. Some neuroscientists and philosophers propose that consciousness itself may extend beyond the individual. Collective consciousness, the shared awareness among humans, or even across species, suggests that the boundaries of experience may be wider than our own minds. If time and reality are interconnected, consciousness may not be confined to single brains but entangled across networks, generations, and perhaps even dimensions. This idea resonates with both mystical intuition and emerging scientific models of information, suggesting that awareness may ripple across the labyrinth of time in ways we barely comprehend. Consciousness also provides the emotional resonance that binds narrative and meaning. It is why we marvel at the night sky, feel the weight of entropy, fear the paradoxes of time travel, and dream of eternity. Without consciousness, the universe is indifferent. With it, the universe is epic, dramatic, and deeply personal. The interplay of awareness and time allows for introspection, creativity, imagination, and wonder. Each moment is transformed from an event into experience, from physics into poetry. Ultimately, consciousness may be the final frontier in our exploration of time. All the equations, all the theories, all the cosmic structures converge upon it, yet none can fully account for it. It is the phenomenon that experiences the labyrinth, asks the questions, and imagines the possibilities. It is simultaneously ephemeral and eternal, biological and universal, bounded and expansive. In this sense, consciousness is the ultimate navigator of the hidden labyrinths of time, bridging the finite and the infinite, the known and the mysterious. In contemplating consciousness, we confront the profound unity of the universe and our place within it. We realize that time, memory, destiny, entropy, and eternity are not abstract concepts but lived experiences, filtered through the lens of awareness. The cosmos is vast and complex, yet consciousness grants us a window into its depths, a means to touch, if only fleetingly, the infinite. It is the heartbeat of the labyrinth, the light in the dark corridors, the guide that carries us through the mystery of existence.